All right, so in section one, you learned how to work out a problem. You went through all these steps. You got row one plus row two, and it made a new row two, and you did row one plus row three, and it made a new row three. Well, sometimes as you're doing this, you'll get going along, and all of a sudden, everything will cancel out and leave you with something like this, where it says 0, 0, 0 equals 10. You're like, that's not possible. I can't have no, I have 0 x's, 0 y's, 0 z's. I don't have any of those, but yet I get 10. That's like saying I have 0 chickens. I don't go to the store, I don't leave house, but yet somehow I end up with 10 extra eggs. It just doesn't work that way. Okay, in order to have eggs, they had to come from a chicken somewhere. So you can't have 0 chickens and get 10 eggs. It just doesn't work out. Okay, I guess you could have duck eggs, but you can't have chicken eggs if you don't have chickens. So, anyways, if you ever get 0, 0, 0 equals 10, something's not jiving because it's saying that we don't have any of these, but yet we equal 10. Okay, I don't know how you can get 10 sheep in your corral if you haven't counted any going in. If your corral is empty and you're turning around and you haven't put anything in, and all of a sudden you got 10, somebody just gave you a gift, I guess, but it doesn't really work out. So, anyways, if you get 0, 0, 0, and then a number, that's not true, no solution, okay? Now, if everything goes away and you get 0 equals 0, that's infinitely many solutions. And then you could actually go back in and solve, like you could have x plus 2y equals some number, and you could solve um, x equals, x equals negative 2y plus 7. And then you can even go further. Do you remember this last chapter we said y equals a? So now x equals negative 2a plus 7, and then you could plug these in and you could get z in terms of a. So anyways, that's just saying this a shows how they're all related. So when you plug in a 1 for a, you get what these three numbers could be. When you plug in a 2 for a, you get what the next three numbers could be. So this is the more correct way to write it when you have infinitely many solutions, is that you would write a's in there. So um, anyways, that's important to know. When this happens, they'll also say that this is dependent equation with infinitely many solutions, okay? So anyways, you could also have two parallel lines. That's inconsistent. That's like this one up here. They never intersect. And when you have like, these aren't plane lines, these are actually planes because they're three-dimensional. Okay, that's a really horrible drawing. But anyways, those are two planes that intersect, and yeah, it looks like an airplane. Put a little propeller on him and a wing. Yeah. Anyways, that's horrible. But anyways, if you want to see a good picture, look on page 577 of your book, and it shows you the different options that are available. So, anyways, now the heart of this lesson is I wanted to teach you how to use your calculator to do this. Okay, so I made you do it all by hand. Um, Now what I want to do is teach you how to use your calculator. Just so you're kind of aware, I'm going to show you two different methods on your calculator. One of those methods, I'm going to use a very simple problem, 3x equals 12. Well, to get rid of this x, we've been dividing by 3 our whole lives, right? Because it's 3 times x. Well, then remember, dividing by 3 is really the same as multiplying by 1/3. So this is really the inverse of 3. So see how I'm multiplying 3 by its inverse? And then I do the same thing over here. I multiply 12 by 1/3, and I get that x equals 4. So really what I did is I said, I'm going to take whatever this number is, and I'm going to multiply it by its inverse. So whatever this number is, if I call it just a coefficient, I multiply by its inverse. That's what this little negative 1 means. It'd be 1 over k, right? And those k's would cancel off. And what I do to one side, I multiply to the other. So what we're going to do is we're going to really break this problem so that or these matrices into what's called a variable matrix not like that. So this is our coefficient matrix, which is like -1, 2, 7, 10, -20, -70, -1/7, 2/7, 1. And you'll learn how to multiply these later. But you'd find out you'd get three equations that it look like this. And over here's our answer matrix. Okay. We call this matrix B, we call this matrix A, and this is our variable matrix. Okay, so if I have A times, we'll just to simplify things, put an X in here for our variable matrix. So I have matrix A times matrix X equals matrix B. Well, if I want to get this X alone, I need to multiply this by its inverse. You know how we had 3 and we multiply it by its inverse and those went away? So the inverse of A is A -1. Okay, and what I do to one side, I must also do to the other. So now these cancel off. I get X, matrix X equals A -1, so matrix A inverse times B. Okay, so that's how we do it one step on the calculator. So now let's pull up our calculator. Come on, calculator. Oh, hold on. So before I hurry and go to the calculator, let's hurry and work out 27 and a few others, and then I'll just show you straight the calculator. So on 27, I have a problem. I have numbers on both sides, or variables on both sides. So I'm going to minus the 2x from each side and minus the 40 from each side. Okay. So really what I end up with is -2x plus 5y minus 16z equals -40. Okay. Then on this one, I have 2x plus 2y. So that's distributing the 2. I'm going to minus the 4z over equals 0. So that's going to be this 2x plus 2y minus 4z equals 0. And the bottom one is good. So that's a 40. So that problem's good. And then 24, I've already got it set up. I'm just going to write it in black because I'm weird. Because I'm going to copy it. So anyways, all right. Okay, back to where we were with this original problem that I started work with you on. This was number 32. Okay, so onto the calculator screen so that we can look at it. Now that we're on the calculator, there's a button that says matrix right under math in blue. So I hit second X then -1. Like I said, I'm going to show you two different ways to do this. I move it over to edit. You have to do this on one method. And I'm going to make it a 3 by 3 because I'm going to work with this part, which is matrix A. So it's -1. Whoops, I need to go back, make sure it's a -1, 2, 7. So now on to my second row. 10, -20, -70. Now the third row, -1 divided by 7, 2 divided by 7, and 1. So that's just taking the variables. You know how he said matrix A is just these numbers that have the coefficients without the variables? So I've gotten rid of the variables. I've just taken the coefficients of those, okay? So it's just like we'd normally write it down. We just take the left side without the equal, okay? And we make that as matrix A. Now I go second matrix, edit, and I'm going to go down to B. So I'm going to edit B. So it's a 3 by 1, 3 rows by 1 column. So 3 rows, 1 column. So matrices always go rows by columns when we define them. Okay, so 3 rows, 1 column. So then I get 14 is my first one, negative 140 is my next one, and 2 is my last one. So I now have matrix A and matrix B. I'm going to quit out of my matrix program. See, so right here by the blue button, it says mode, but above it, it says quit in blue letters. So I hit second mode and that quits. That takes me out. And you're like, we did all that work just to quit? Well, we're going to go back to it now, though. It's kind of a weird process, but that's how you have to do it to get the matrices. So I went back into my matrix menu. I chose A. Now I hit that x negative 1 without the second in front of it, and now it makes it A negative 1, just like we wanted, times second matrix B. So I choose B. So A negative 1 times B, and I hit enter. And it says no inverse matrix exists, calculated result not found if dependent on matrix inverse. So it says singular matrix. Okay? So when it says singular matrix, that means there are infinitely many solutions. So you would just write infinitely many solutions. Like I said, then you should figure out realistically, you should get them so that it's in terms of A, B, or A. So X equals something with A, Y equals something with A, Z equals something with A. Okay? But we aren't doing that. All right, the next question says, so I've chose 27, solve this. So again, I'm going to go back into second matrix, edit. There are 3 rows by 3 columns. So 3 by 3. I'm going to write down these numbers in here. So that's a negative 2, 5, negative 16. And the second row is a 2, 2, negative 4. And then a 1, negative 2, 7. Okay, so now I'm going to go second matrix, edit, go down to B. It's 3 rows. We still have 3 rows by 1 column, so that's still good. So negative 40. It's important you understand rows by columns, okay? 18. So rows go sideways, columns are up and down. Think of like your fancy mansions in the south. You know those big columns? They run up and down. Or your Roman Colosseum, it's because it has those big columns. Columns go up and down, okay? So it always goes rows by columns. All right, so I've got my 3 numbers in. I get out of this. If I've already done it once, you can hit second enter, and it brings up A negative 1 times B again. And I just hit enter, and it gives me my answers. X is 4, Y is 0, Z is 2. And I'm done. Like that's that whole problem. So I could actually write it X equals 4, Y equals 0, Z equals 2. Ta-dum. Okay, like I said, I'm going to teach you another method on your calculator. Okay, so I go back to my calculator, second matrix, edit, and I'm going to go down to C just to keep it different. And I'm going to put in a 3 by 4, so 3 rows by 4 columns. So 3 by 4. So now there's 3 rows, 4 columns. So negative 2 is my first number, 5, negative 16, and then negative 40. Now my next row is 2, 2, negative 4, and 0. And my last row is 1, negative 2, 7, and 18. So I now have this typed into my calculator. Same thing that I did before. I'm going to go out to second quit. But now I'm going to go back to my matrix. And in the middle is a math menu. Okay? So I go to the math menu, and it's kind of weird. I've got to remember which one it is. Okay, so I went out. we go to our math menu. We want it to turn into reduced row echelon form. Remember, that's what we worked on in section 1 was reduced row echelon form. So if you're looking, this says row echelon form, but then B says reduced row echelon form. So if I hit that, and now I tell it which matrix I want it to be, so matrix C, so I want it in reduced row echelon form. Remember, that's where we get 1, 0, 0 some number, 0, 1, 0 some number. That's reduced row echelon form. Well, my calculator is going to do it all for me right here. So now that I've got the matrix C typed in, I hit enter, and there it is. There's reduced row echelon form 1004 01000012. So either way, you can use your calculator. It'll do it for you. The reduced row echelon form or A negative 1 times B. Okay. So now here's the next question. Question number 24. So I go second matrix. Let's do a 3 by 4 again. So 3 rows by 4 columns. 1, negative 3, 17, 1, 2, 2, negative 4, 0, 2, negative 5, 29, 5. Make sure those match. 2, negative 5, 29, 5, 2. Uh-oh, that shouldn't be a 2 there. That should be a 1. Negative 1. 7, 2. I don't know what I did, but something's way off. So 2, negative 5, 29, 5. 1, negative 1, 7, 2. 1, negative 3, 17, 1. 1, negative 3, 17, 1. 1, negative 1, 7, 2. 2, negative 5, 29, 5. So it pays to double check. You know, it's not, you're using the calculator, it's not going to take you tons of time. So now I quit. I go second, not math, second matrix, and then to math, and then it was B. So if I hit alpha apps, that takes me to the B one, because that's the little B right there in green. So if I choose alpha B, that takes me right to it. And I go second matrix. We're choosing C. I could hit just 3, and voila. Oh, but remember what we said about 0, 0, 0, 1? Well, that means there's no solutions. Okay, so that's no solutions on that problem, because I can't have 0, 0, 0 equals 1. It just doesn't make sense. So that's no solutions. So anyways, if I would have tried it the other way, edit matrix A, make it a 3 by 3, 1, negative 3, 17, 1, negative 1, 7, 2, negative 5, 29. Second matrix, go to B. I can already hear some of your words. You're like, why didn't you teach us how to do this in the first place? Why did you make us do it by hand? If I'd have taught you to do this in the first place, you'd have never done it by hand. You're like, well, why do we need to do it by hand if the calculator will do it for you? I guess because I'm weird and I want you to understand what your calculator is doing. I don't know. But no, there are some times when you have to know how to do it by hand, because it's not all numbers. In some of your upper division math, you have to use letters in there. And if you don't know what's going on, you won't be able to do it. So I want to make sure you understand what's going on. I know it's rough to do it by hand. So realize that this is a way to check your work. So this one's no solution. So on the one it said it, okay, so no solution on this one. We already saw that. So anyways, those are the two different ways to do this. I'm using a calculator. That should help your work immensely, and that'll make section 2 go by really quickly. So good luck. Don't hate me too bad because I made you do it by hand. It's good for you. Think of the character I built. I don't know. Just don't hate me. Good luck.